Shri Gurubhyo Namaha students. I hope you people enjoy the online class. Right. Now, I am going to introduce the new concept of application of determinant and matrices. That is combination of determinant and matrices. In exercise 4.4 I discussed determinant. Exercise 4.5 I discussed matrices. The combination of determinant and matrices I am going to teach now, right. Before entering into the topic, I want to refresh you. Whenever you want to learn a new concept that is unknown, we should move from the known. Now I am going to write one thing. You have to see and say the answer, what it is, what it comes to your mind, that you should say. Write AX plus by plus c is equal to 0. When you see the equation, something it come to your mind, isn't it? Right. What it is? It is a equation, linear equation in two variable, or you can say it is a equation of a straight line. Right. Now the next level you people learned. What it is? Pair of linear equation. Pair of linear equation means what? Two equations you are going to take and discuss. Pair of linear. First equation, so you are going to write a1x plus b1y plus c1 equal to 0. Next, a2x plus b2y plus C2 equal to 0. When you see the equation, you people learned. It comes to your mind, isn't it? That's why I said, whenever you learn the new concept, you have to relate with the known concept. This is your known concept. Pair of linear equation in two variable. When you see this, what it comes to your mind or what it spark to your mind? Conditions, right? A1 by A2 is not equal to B1 by B2. When I wrote the condition, it represents what? The two given lines are intersecting. The lines are intersecting. If it intersect means you will get it as a unique solution. Intersecting means you get it as a unique solution. Then you can say the system of equation is consistent. Whenever you arrive a solution, the system we call it as consistent. Now the next condition, A1 by A2 equal to B1 by B2 is not equal to C1 by C2. What it represents? The lines are parallel. It has no solution. The system is inconsistent. Right. Now next, A1 by A2 equal to B1 by B2 equal to C1 by C2. When you see this, what it will come to your mind? That is, the lines are coincident. The system is consistent. It has infinitely many solutions. Coincident means what? All the points are lying on the same line, right? That's all. These are the things are known concept. These are the things are known concept. The same pair of linear equation you are going to represent in the matrix. How I am going to represent in the matrix? You have to listen. That is A1x plus B1y plus C1 equal to 0. Next, A2x plus B2y plus C2 equal to 0. This is the pair of linear equation. You are going to write it in terms of matrix, right? First you have to collect the coefficient of x. When you collect the coefficient of x, you should write it in the column wise, right? How to write? A1, A2. Next, you have to collect the coefficient of y. that you place it in the next column, that is second column, B1, B2, right, into X, Y equal to, the plus C1 will move to that side, the constant, that it comes to in the place of minus C1 minus C2. We have to check whether will you arrive the equation or not. See, first row, one column, right? First row, first column, that is A1x plus B1y equal to minus C1. Next, A2x plus B2y equal to minus C2. When you shift minus C1 and minus C2, you will arrive the pair of linear equation in two variable. Today I am going to discuss how to solve the pair of linear equation using the matrices and determinant. Now I am going to teach how to solve the pair of linear equation in two variable using the matrix, right? For that I will tell you the condition. First you have to check determinant A is not equal to 0. You have to find, first you should find out determinant A. If it is not equal to 0, the system is consistent. The system is consistent. It has unique solution. Next, if suppose the determinant equal to 0, we have two cases. That is, if the determinant is not equal to 0, the matrix is non-singular. The matrix is non-singular. If the determinant equal to 0, the matrix is singular. The matrix is singular. Here the matrix is non-singular. Here you can get a unique solution. Here if the determinant equal to 0, two cases arise. First, case 1. We can evaluate adjoint of A into B. Evaluate first. If the determinant equal to 0, evaluate adjoint of A into B. If, first case, if adjoint of A into B not equal to 0, adjoint of A into B not equal to 0, the system is inconsistent. The system is inconsistent. It has the system is inconsistent. It has no solution. It has no solution. Second case, if adjoint of A into B equal to 0, the system either consistent, either consistent or inconsistent. or inconsistent. If the adjoint of A into B not equal to 0, the system is inconsistent, it has no solution. Here, if adjoint of A into B, if adjoint of A into B equal to 0, the system is either consistent or inconsistent. Consistent means the system has infinitely many solution or no solution. The system is infinitely many solution or many solution or no solution, right? Again I repeat, first you have to check whether the determinant, you have to find determinant. Then determinant A is not equal to 0, you conclude that the system is consistent, it has unique solution. Suppose if your determinant equal to 0, you want to evaluate adjoint of A into B. In that case, if it is not equal to 0, the system is inconsistent, it has no solution. Suppose your adjoint of A into B equal to 0, the system is either consistent or inconsistent. If it is either inconsistent or consistent, it has no solution and infinitely many solution. Now I am going to move to the exercise. Exercise 4.6. Now we want to, these equations are represented pair of linear equation I discussed. Now we are going to check whether it is consistent or not. First, while examine whether it is consistent or not means we need to find determinant A. We need to find determinant A. Now the pair of linear equation, I am going to write it in terms of matrix. How I am going to write it of matrix, you see. The coefficient of x. What is the coefficient of x here? 1. What is the coefficient of x here? 2. So that should be enter into the first column. Right? Now coefficient of y, you have to gather and write it in the second column. That is 2, 3. What are the variables are here? X and y. So that should be in a column matrix. The coefficient of x in the first column, coefficient of y in the second column. The variable which used is x and y, that should be in the column matrix equal to, what is the constant? That is 2, 3. In general, it can be represented as capital A. The coefficient of x and y you gathered and written in the matrix, that is capital A. X and y you write it in the column, that should be represented as capital X. The constant you should represent it as capital B, right? Coefficient of x and y, the collection of coefficient of x and y as capital A. The variable x and y is capital X. The constant is represented as B. What I said, how to examine the system of equation is consistent or not? For that we want to find determinant A. Determinant A. The matrix you are going to transfer into the determinant. Determinant 1, 2, 2, 3, which is equal to, you know, in 2 by 2 determinant, how to find the value we discussed, isn't it? Once again I teach you product of main diagonal minus product of sub-diagonal. So 3 minus 4, which is equal to minus 1 not equal to 0. See, if determinant A is not equal to 0, what I said, the system is consistent. Determinant A not equal to 0. Therefore, the system is consistent. Once again I repeat, if the determinant A is not equal to 0, the system is consistent. System means what? The given pair of linear equation represent consistent. It has unique solution. Right. If pair of linear equation is given, you know whether the lines are intersecting, parallel or coincident. For that we learned A1 by A2 is not equal to B1 by B2. The same pair of linear equation, when you transfer into the matrix, you should check what is the determinant A. If it is not equal to 0, your conclusion is the system is consistent, it has unique solution. Next, question number 3. X plus 3y equal to 5, 2x plus 6y equal to 8. The first sum, what I said, you have to collect the coefficient of x and coefficient of y. Collection of coefficient of x, you have to write it in the first column. So, 1, 2. Collection of y, that should be in the second column. Then the next I said the variable 2 things are there. Here 2 equations, so we are arriving 2 by 2 matrix. The x and y variables are used, so you have to write it in a column matrix, which is equal to the constant also you should write it in a column matrix. I said the collection of x and y should be represented as capital A. X, y variable, that should be represented as capital X, which is equal to the constant should be represented by capital B. The question heading is what? Examine the consistency. Right. If you want to check whether it is consistent or not, means you want to find the determinant A. Right. The matrix you are going to transfer into the determinant. Determinant equal to determinant A equal to determinant 1, 3, 2, 6, which is equal to product of main diagonal minus product of subdiagonal. You arrive the result as 0. I told you, if the determinant equal to 0, we want to evaluate adjoint of A into B. Then only you can conclude whether it is consistent or inconsistent. Right. Now I am going to see determinant A equal to 0. First step, what we want to do? Evaluate adjoint of A into B. Adjoint of A, if it is 2 by 2 matrix, how to find adjoint of A? Change the main diagonal entry, change the symbol of subdiagonal entry. If it is 2 by 2 only, it is possible. So, what is your matrix A? 1, 3, 2, 6. I am going to interchange the entries in the main diagonal. So, what I can get? 6, 1. Here, change the symbol of subdiagonal, that is minus 3, minus 2 into, what is our B here? 5, 8. Okay. You are going to multiply, which is equal to first row, first column. Right. 6 5s are 30. Sorry. First row, first column. What you will get? 6 5s are 30 minus 24. Next. Second row, first column. Second row, first column, what you will get? Minus 10 plus 8, which is equal to 6 minus 2. Definitely it is not equal to 0. Definitely it is not equal to 0. See here, determinant A equal to 0, then what you want to find? Adjoint of A into B. If your adjoint of A into B is not equal to 0, the system is inconsistent. The system is inconsistent. If it is inconsistent, it has no solution. Therefore, the system is inconsistent. It has no solution. Right? First, what you did? The coefficient of x, you write it in the first column. Coefficient of y, you write it in the second column. The variable, you arrange it in the column matrix. The constant, you arrange it in the column matrix. I said the collection of x and y is represented A. Y variable can be represented by capital X. Constant should be represented by capital B. You want to examine whether the given equation is consistent or not. For that purpose, first you want to find determinant A. If you arrive determinant equal to 0, you want to evaluate. You cannot conclude whether it is consistent or inconsistent. For that purpose, you want to evaluate adjoint of A into B. Here it is a 2 by 2 matrix. The adjoint of A, you have to change the main diagonal entry, change the symbol of subdiagonal into B. You have to multiply the first row, first column, that is one column only. Right. Next, second row, first column. You arrive 6 minus 2. Definitely it is not equal to 0. Then adjoint of A into B is not equal to 0. What is your conclusion? You write it here better. Adjoint of A into B is not equal to 0. Therefore, the system is inconsistent. It has no solution.